graph on the previous slide, calculate the work done against the gravitational force in moving the 10 kilogram object from a radius of 1 times 10 to the 7 to 2 times 10 to the 7 meters, and hence find the gravitational potential energy gained. Now, basically that is asking us to do one thing. If we are finding the work done against the force, that's the amount of energy changed. That amount of energy is just changing into gravitational potential energy. So it is a wordy question, but all it is asking for is the change in energy. So if we look at our graph, nicely they've shaded the bit we need to look at. So we've got an object that is 1 times 10 to the 7 meters away from the center of the Earth, and we are raising it out to 2 times 10 to the 7 meters away from the center of the Earth. Now, by the way, we're going to do a lot more of these types of examples in chapter 1 when we get there. Okay? But for now, all we need to do is to be able to read the graph. So if we look at our graph, if we look first of all, we are going to have to count squares. Come on. Sorry, having stylus problems today. Oh, we've got some answers already. That's good. All right. So if we look at each square, hopefully this will work now. Yeah, there we are. So each square, pretend that looks like a square, is 10 newtons high and what is it? 0.25 times 10 to the 7 meters across. Okay, there's 4 of them between 1 and 2, so there must be 0.25 each. So, what does that give us? 2.5 times 10 to the 7. So each square is worth that many joules. So we just have to count up our squares. 1, 2, 3, 4, 5, 6, 7, 8. I'll call that 9. But I think they would allow it with anywhere between maybe 8 and 9. Probably not 10, I don't think. Okay, so that should come out to be 2.43 times 10 to the 8 joules. Okay, that's it. Again, you just... Oh, hang on, am I off? Oh, hang on, I am off. I did... Yep, sorry. Teaching moment, just seeing if you're awake. The more I say that, the more likely you are to believe it. You know, it'll become a conscious thing. All right, there you go, 2.25 times 10 to the 8. So again, we are just finding the area under a graph. This is where this on your cheat sheet will be really helpful. Make sure you have a graph, and so you know straight away if it's force against distance, the area under that graph is the work. And this is really important because I'm going to show you another example in a second where it gets super confusing if you don't keep that in mind. Okay, so for now though, have a go at the next one.